Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous few lectures we have been discussing numerical Python package, NumPy package, and in the previous lecture we started our discussion on pseudo random number generation. So, let us discuss few points that we were able to discuss in the previous lecture and then we will pick up from there. So, we talked about pseudo random number generation, and we said that these numbers they are generated by an algorithm with deterministic behavior based on the seed of the random number generator. For this we used numpy.random module, which we have been some of the functions from this module we have been using in the previous lectures as well. For example, random dot random function. So, these modules can help us for example in generating samples from the normal distribution. So, for this we can use the normal function. So, numpy dot random dot normal function. So, default values as we discussed it can be used to generate a standard normal distribution as well. So, we talked about, we did few exercises here, we use np dot random dot normal to generate these numbers and create this 2-dimensional array. Then we talked about the Python's built-in random module also, and the limitation of this module also, how we will have to use a list comprehension which involves a loop construct to actually achieve something like a 1-dimensional array, and how easily that can be done using np.random.normal function in one go. So, we looked at those examples as well. Then we talked about the changing random number generation seed, and because this kind of functionality is really useful in the analytics context, as we said, because sometimes for different candidate models we would like to have the same observations in different partition and compare the results. So, seed value will really facilitate the random selection of the observation into different partition. Then we talked about the random function, which is actually conform to the standard normal distribution, and we looked at that also. Then we talked about the state aspect of these particular random number generation, that there is something called global state, which is typically used to generate these random numbers. However, if situation demands that we would not like to use the global state for the random number for these random functions, and rather we would like to manage or alter the state manually, and therefore we would like to have our random number generator isolated from the global state. So, that can also be done. So, for this we can use random state function. So, to create a random number generator RNG and use it for further calls, we can use this np.random state function. So, you can see in this particular line of code, we on the left hand side we have RNG, a new random number generator, an isolated random number generator isolated from the global state that we want to create, and for this we are using np.random state function. We are passing on this value 1 2 3 4 5, and if I run this we will have an isolated state. And if I perform the same kind of operation where I am trying to dot 10 values conforming to standard normal distribution using the random function. Now, you see especially focus on the code line that I have written here, rng.random. Earlier it was np.random.random. Now, it is rng.random, because we have created a isolated state for this generator. So, therefore, every time we want to use this isolated state, we will have to use this particular object RNG. So, RNG dot random and then 10. If I run this, we will get the 10 values. So, the only difference is this particular state is isolated from the global state. Now, we can also look at the state. So, earlier we had used get underscore state function. So, here also we can call RNG dot get underscore state. So, this output will reflect the state of this particular random number generator. The earlier previously when we had called np dot random dot get underscore state, that was the output was reflecting the global state situation. So, if I run this, we will have these values which indicate the state of this particular generator, but we will not go into details of this. Rather we will focus on another aspect here. Rather it is an example which is sometimes really useful in the context of analytics, random walks. So, this is an interesting concept which is used in modeling. For example, many people believe that fluctuation in stock market prices, they are actually random walk. So, essentially when we say random walk, that means the next values are going to be only dependent on the previous value. So, therefore, there is not much sense in making prediction of any series which is a random walk. So, here we are talking about, when we are talking about stock prices, we are talking about the time series data, and if that is a random walk, then maybe it will not help us much in terms of making prediction about those prices. However, how we can create random walks, that we are going to focus on now. So, in this context we can define a simple random walk like starting at 0 with the steps 1 and -1 occurring with equal probability. So, this is also a simplistic way of defining a random walk, or we can call it a simple random walk. So, how we can create this simple random walk using Python built-in capabilities. So, let us focus on this. So, we have a random module and there also Python built-in capabilities. So, we will import this, import random, and then we have x. This is something that we will use for simple random walk. So, walk equal to we are creating a list, we are initializing a list with these x values, which is right now just with the one element 0. So, we will be working on the value of x, and we will be appending this list this walk list here. So, number of steps 1000, we will take 1000 steps, and therefore 1000 values will be appending to the this list object, that is walk, and for that we will be working on x. So, we are running a loop for loop here for I in this range. So, 1000 values we will run this, and then step 1, step equal to 1 if random dot rand. So, this is the function that we are calling here, random dot rand int. So, between 0 and 1, else -1. So, we will pick a value from here using this function, and based on that we will either give step as value 1 or -1, then we will be using that value to update x, and then add that x is going to be appended in the list that we have, that walk object that we have. So, in this fashion we will be creating this. So, let me run this, and you can see if I look at the walk. So, you can see the values 0, 1, 2, 3, these are the values of walk here, and if I want to generate a plot here, then this aspect we have used before also, though we are yet to discuss the visualization, the plotting aspect in more details later on. We will cover it later on. So, right now we can use this magic command percentage matplotlib inline, and then import this Roorkee library module matplotlib.pyplot as plt, and then we will have access to this function plt.plot, and we can pass on and plot these 100 values from walk. So, if I run this, so you can see in the output the walk values, they have been plotted here, and you can see here in the output. So, this is very much similar to what we see in stock prices. So, stock prices you can see, if you see because the fluctuation that we see is in a pattern is going in any direction if we look at day to day changes. So, therefore, that is why many people believe that stock prices they are actually random walks, and also many people believe that, and statistically they prove that that it is very difficult to make prediction of series which follow a random walk. So, now that was using the built-in random module. Now, we can use np.random module to perform the same thing. Now, you would see that it would be much easier here we won't have to run a loop to achieve that thing. So, you can see first thing to notice that no loop required. So, first thing we are calling np.random.randint function. So, here again the value would be 0 and 2. So, the value actually would be using this function we would actually be getting either 0 or 1, and for 1000 steps we will run this this particular function, therefore 1000 values will have. Then we are calling np.where function, where the previous output draws that we had just that we will get using randint function, they will be compared with 0. If greater than 0 then 1, otherwise minus 1. So, we will have an array 1 and minus 1, and then we will have the walk 1 where we can actually compute this cumulative sum of these values. So, let us run this. So, let me run this and let us have a look at the draws, the first output. So, you can see these are the draws here, and then walk 1 you can see these are the values, and then we can plot this again, and you can see this kind of these kind of values and this kind of plot we have obtained here. So, this is how using different modules, one using the numpy's random module and one using the built-in module, and how we can generate these plots. And you can see that numpy random module makes it slightly easier and faster and convenient to actually create these random walks. Now, few statistical operation can also be performed on on these walk objects. So, let us talk about minimum value. So, along this walk's trajectory we can call this win method here. So, walk1 dot min, and we will be able to compute the minimum value in this path. Similarly, maximum value along the walk's trajectory. So, we can use this method max. So, walk1 dot max, and we will get the maximum output. So, here you can see 27. Now, if we want slightly complex statistics to be generated from this trajectory, this walk's trajectory. So, that can also be done. For example, first crossing time. So, what this is about? This is a step at which the random walk reaches a particular value. So, let us say that value is 20. So, we would like to find out the step the first step at which this value was actually achieved. So, this is what we are referring as first crossing time, first time then when this random walk actually crossed that particular value. So, this can be done using argmax function. However, we will have to do certain processing before we reach to the final output. So, what argmax function does, it returns the first index of the maximum value in an array. So, let us say 1D array given, it will have a maximum value, but it might appear many times in that array. So, what argmax function will give us, it will return the first instance of that maximum value. So, let us apply this walk 1, let us apply this argmax method on walk 1. So, walk1 dot argmax, and 890 is the first index where this maximum value 27 has been reached. We can check it back, we can confirm it back by accessing this index. So, if I try walk 1 and within the brackets if I pass on 890, so you will see we will get 27. So, out of 1000 indices that we have, it is the 890th index where we actually reach this particular maximum value 27. Now, we wanted to actually implement the first crossing time. So, for that we will have to use this Boolean array. So, in case of a Boolean array, true is the maximum value, because Boolean array would be comprising only true and false. So, in a numeric sense, true is the higher value, it typically represented by 1, and false is typically represented by 0. So, therefore, if I run a argmax on a Boolean array, the implementation will allow us that in that sense that true would be treated as the maximum value, and we will get the first index will get the first index of the true value there using our max function. So, what we are going to perform is to achieve the first crossing time statistics, we will use R max function on the on a particular expression, Boolean expression to achieve this desired result. So, if you look at the expression that we have in this line of code, what we are doing is np dot abs. So, we are calling the absolute function, we are passing on this list walk 1, and from here we are comparing this we have the conditional statement, we are comparing it with the 10 greater than or equal to 10. So, if we look at the absolute values of this walk 1 list, if all the elements where the value is greater than or equal to 10, they would be turned true. So, now out of this will be a Boolean array. Now, we are applying argmax on this particular Boolean array dot argmax, as you can see in the code. So, therefore, the first instance of true value will be returned, and that would actually be the same as the first crossing time. So, if I run this, we get 29, and if I access walk 1 29, if to just to confirm, you can see the output is 10. So, at this particular 29 index, first time this particular value of 10, this absolute 10 label was breached. So, this is how slightly complex statistics can also be easily computed using numerical Python package. Now, let us take another example. Now, this time we would be implementing multiple random walks. So, let us take for example 50 walks of 1000 steps each. So, let us say n walks is equal to 50, then number of steps in each of those walks 1000, then we will draw the then we will perform the random draw. So, we are calling np dot random dot randint 0 comma 2, size is given n walks comma n steps, and so this will randint will return us 0 or 1. So, we will have this 2D array filled with these values, and then we will use np dot where function to actually we will compare draws 1 with 0, or we will make it 1 or minus 1 to actually implement the random walk, and then we will take the cumulative sum to actually achieve that. So, so this would be along the second dimension, that is why you see that steps 2 dot come sum 1, because for every walk, because we are having 50 walks, for every walk we will be performing this separately. So, come sum on the axis 1, that is second dimension. So, if I run this, let us have a look at the steps 2. So, you can see here this is a 2D array here filled with the 1s and minus 1 values as you would expect, and then walks 2. Here you will have the cumulative sum. So, you can see this is also 2D array, and you can see clearly if we perform the cumulative sum pluses and minuses, and then you will have these values. Now, if I just to confirm the dimension here, if I access the shape attribute here, so 50 elements in the first dimension, that is because 50 list we have, that means 50 walks we have, and in the second dimension we have 1000 elements, because each of those lists, each of those walks will have 1000 steps, 1000 values there. So, that is why this dimension. Now, from walks 2, and if we call the min method here, we will get the minimum value across all walks that we have. So, that comes out to be minus 86, and similarly we can also find out the maximum value that will be across all these elements. So, walks 2 dot max, this is 103. Now, if we want to implement the similar kind of slightly complex statistics there, when we just had one walk, we implemented first crossing time. Now, here we are having 50 random walks. So, instead of first crossing time, let us find out out of these 50 walks which walk actually had the minimum crossing time. So, that is something an interesting statistics that we would like to find out. So, minimum crossing time for any of the walks to reach a particular value. So, let us take absolute 30 label. So, again so first we will find out which of the walks reach the value. So, for this we can see we are trying this in similar kind of code here. NP dot abs of walks 2 we are looking at just the absolute value. So, greater than or equal to 30 dot any 1 to dot any along the we are passing the axis as 1. So, that means along second dimension, because we would like to work on different walks, and any of these dimension whether they have breached, because not all of these random walks might be breaching this absolute 30 label. So, first we need to find out which one of them is actually breaching that. So, using this expression we are just doing that. So, we will have a Boolean output, and you can see 1D Boolean array with so we will have, you can see in this list we have 50 values, 50 walks, and not, you can clearly see there are many false values. So, not all walks have actually breached this absolute 30 label. Now, number of walks hitting 30, if we want to find out that count. So, we can use hits dot sum function, and we will be able to find out how many actually breach that label. So, if I run this, you can see output is 37. So, out of 50, around 37 walks actually were able to hit this absolute 30 label. So, now our idea is to find out the label minimum crossing point. So, for this again we will use the argmax function. So, you can see here the code is quite similar to previous lines that we have used. NP dot abs walks 2. Now, we are just working on the hits, the walks which have actually breached the 30th label and greater than or equal to 30 dot argmax. And so, this will again be along second dimension, because we are working on walks. So, here again we will get the the output would be Boolean array 1D array, and from there argmax will find out the first instance where that happened, and therefore, in the first hits we will have those indices. So, for all of those 37 walks that breached the 30th level will have the indices where it happened. So, let me run this and first hits. Now, if you look at the output of first hits, so I think it would be 37 values, and if you look at the different, so for different walks different index is there to breach this label. Now, let us find out, let us use the min method to find out the minimum crossing time here. So, we will call it MCT and the first hits dot min. So, if I run this, and you see that 135. So, if you look at the output number 483, 484, you can see 135 is the index, is the minimum index label where we breached the absolute 30 label. And if you look at the output 483, so you can see it is actually the fourth value in this output, that is actually 135. Now, if we want to confirm some of these things, so what we will do, we will run few more things here. So, what we are going to find out now in the output number 483, the index where this minimum value was achieved. So, for this we are writing this kind of code, list of first hits is equal to MCT. So, the elements where this MCT happens, because there can be more than one instances, as you can manually see in the output number 483. There I can see, I can at least clearly see two values with 135 index. So, then we will apply index true. So, we will find out which one is the first index there. This is another way to find out this thing, index method. So, if I run this line of code, 3 is the output. So, you can see in the output number 483 it is actually third index. Now, that we can check manually also, but through code also we can confirm the same. So, all this is 0 index. So, it is actually 0, 1, 2 and 3 is the fourth value. Now, if you want to find out the index of true value, so out of 37 true value that we earlier worked on, so index of the true value among these 37 true values here. So, So, we can find out that again for this we can use this code. So, we are going to count true and we are running a loop to find out the true value, which is MCT underscore IND plus 1th among true values in hits array. So, in hits array we had 37 values. So, which index was this fourth value, fourth true value. So, we are essentially looking for fourth true value in the hits array. For this we will have to count the true values here, and we are running this loop, and you can see for I in range length of hits, and if count underscore true less than MCT, then and if it is true, then we will update the count. Otherwise, if otherwise we will continue, and then if the condition of count underscore true is violated, it is not less than or equal to MCT IND, then we will break out of this loop. So, let me run this and let me check the value of I. So, it comes out to be 8. Now, the appropriate index would be less than would be I minus 1. So, in the walks2 array that we had, we will use I minus 1 and MCT to find out whether at particular that index, that minimum crossing time 135, whether we really had reached the 30 label. So, if I run this, you can see the output 30. So, I minus 1 that and MCT in that particular walk, in that means it happens to be 7th index. That means in the 8th walk we reached the 30th level at the minimum crossing time, that was 135th. So, this is how these kind of interesting statistics can really be generated. So, with this we are able to complete our discussion on numerical Python aspect, that is relevant in the analytics context. And now we will start our discussion on another important package, which is Pandas. So, for this we have created another script here, another file. So, I will run this. Now, we will briefly start our discussion on this particular package, and then we will continue in the next lecture. So, we now have a good enough view of numerical Python package. We have looked at Python basics, we have looked at built-in capabilities that are there, we have looked at the numerical Python package. Now, we are going into the Pandas. Pandas is the real package which will facilitate our much of our important task in the analytics that we have to perform. So, this package actually is used to work with the heterogeneous or tabular data. So, typically as you might be familiar with other NPTEL courses, business analytics and data mining modeling using R part 1 and part 2, that we are typically dealing with matrix format data, tabular kind of data, and there each column is going to represent a different kind of variable. So, those are the kind of data sets that we typically deal with. So, it is the Pandas package which typically helps us in facilitating in working with those kind of data. So, Pandas package used to work with heterogeneous data, tabular data, facilitates faster and easier data processing. So, that now, so from this discussion onwards, this part of the Python, the Pandas package, we are going closer to the our analytics aspects, where we will see how Python is going to be really useful in the analytics in general and text mining modeling in particular. So, more focus is required from Pandas onwards. So, to import the this particular package, we can write this import pandas as PD. So, first thing is pandas is the name, full name, and we would be using this abbreviation here. So, first run this, and then frequently used libraries would be series and data frame. So, we will be talking about these two important data structures, series and data frame here. So, you would see that data frame, the name is quite similar to the data frame that we have in our platform. So, you will notice slightly similarities in terms of data frame structure that we have in the Pandas in Python, and what we have learned in our platform in those two previous courses. So, for this we will be importing these libraries series and data frame. So, let me run this. Now, the next thing is our discussion on these two important data structures, series and data frame. So, we will stop at this point and we will pick up our discussion on these data structure in the next lecture. Thank you.